Today we are going to solve systems of equations by elimination. And to eliminate means to get rid of. And so the key thing is to eliminate a variable. And that's what we do when we substitute as well. However, in this case, we are going to add the equations together. And so in order to add them together to eliminate one of the variables, we need to have opposite signs but the same coefficient. So opposite coefficients, opposite signs, same number. So like we have here, a negative 2y plus a 2y, those will cancel out when I add these two equations together. And that's what I'm going to do here. I'm going to add these together, and when I do that, x plus 5x gives me 6x. Well, you see, the negative 2y plus the 2y makes 0. So that term cancels out. And here I bring down the equal sign. I do negative 19 plus 1, and that gives me negative 18. So all I have to do from that point is do one operation to solve for x. And that is to divide by 6 on both sides. So when I do that, I'm left with x equals negative 3. So that's the x value, but we still have to do the substitution. So now I have to take this x value and substitute it back into one of these x's. And I'm going to pick this top equation and put it in for that x right there. So I'm going to rewrite that equation, but in place of x, I'm going to write the value that x is. So x is negative 3. And then I'm going to bring down the minus 2y. And then I'm going to bring down the equal sign, equals, and then the negative 19. So I just rewrote the equation, just substituted like we typically do with substitution once we solve for one of the unknowns. Well, I've got two steps to do here. I've got to add 3 to both sides first. And when I do that, I still have that negative 2y, and this all equals negative 16. So from there, all I have to do is divide by negative 2, and we've got our answer. And so the value of y is 8. So now we have x and y, so we can write down the ordered pair. And so the ordered pair is going to be negative 3, positive 8. So this method works really well when x's and y's are lined up. When you don't have a variable solved for, this is the method to use. Well, the next two problems require an extra step. We just can't add the two equations together. So if you look at this first equation, 2x plus y equals negative 5, I have another equation with the 2x, but this time a minus 5y equals 13. So you see, if I added these together, I would get 4x. The whole idea is to eliminate one of the unknowns. Just like I did here, I crossed out those y terms. So I can't cross out these x terms because they're not opposite sign. So what I need to do is take this top equation, or the bottom for that matter, and I need to multiply it by a negative 1. And what that will do is it will make this x term here negative. So now it's going to be negative 2x, but you got to multiply every number by that value. So negative 1 times y makes a negative y. And negative 1 times negative 5 makes a positive 5. So now we're ready to add the two equations together. So I'm going to add the modified equation with the bottom equation of that original problem. And now I get these x terms to cancel. And so what am I left with? Well, these two terms add together because they're the same sign. They make negative 6y. Over here I add this, and that gives me 18. So looks like I'm going to end up dividing by negative 6, and it'll end up going in there evenly. And so I do that division, and we'll have our answer. Y equals negative 3. Well, we're not done yet. Still the same thing as before. We have to substitute. So I'm going to take this negative 3, and I'm going to substitute it in for y in that top equation before I modified it. So let's rewrite that top equation. 2x plus y. See, it's 2x plus y. But in place of y, what are we putting? Well, we're putting what y is, negative 3. So plus negative 3 equals negative 5. So where did I get the equals negative 5? It comes from that equation. So I just rewrote that equation, but in place of y, I put negative 3. So from that point, we just move terms around. So that negative 3, I can add 3 to both sides, and that will cancel out the 3 on the left-hand side, leaving me with 2x equals negative 2. So from that point, just have the one step here. I'm going to divide by 2 on both sides, and that will give me my answer of negative 1. So x equals negative 1. So my answer for this problem would be negative 1 comma negative 3, and that is our solution. Well, the next problem is similar. So what's similar about this one is that we have to multiply by a number, a negative 1, to cancel out one of these unknowns. And here we've got 3x plus 3y equals 15. Down below, negative 2x plus 3y equals negative 5. So we want to cancel out the y terms in this case rather than the x terms. They're the same number, but just not opposite sign. So the way we're going to do that is I'll take that top equation and I'm going to multiply it by negative 1. So each of those numbers on top gets multiplied by a negative 1, and we'll rewrite our equation down below. So it becomes a negative 3x. Again, negative 3x times negative 1 makes the negative 3x. 3y times negative 1 makes a negative 3y. And this all equals negative 15, because 15 times negative 1 makes negative 15. So all the signs switched on that top equation, which allows me to add these together to cancel out this y term. See, those are the same number but opposite signs, so they will cancel. And so what we're left with is a negative 5x. It's negative 5x because they're the same sign, so I add them and it stays negative. Over on the other side, same thing, same sign, so it stays negative, and I add negative 20. So one step to solve for x, and that is to just divide by negative 5. And so when I do that division, the negative signs cancel, and 5 goes into 20 4 times. So x equals 4. Well, one more step, and that's just to substitute. So we're going to take this 4, and I'm going to put it back into one of the equations. I'll put it into that top equation, and I'll put it right in there for x. And so when I do that, I rewrite the equation, which would be 3x, but in place of x, we're going to put 4, because that's what x is. And then bring down the plus 3y equals 15. So I go ahead and multiply some numbers there. 3 times 4 makes 12, plus 3y equals 15. And then we can do some opposite operations to solve. So that opposite operation would be to subtract 12 from both sides. And when I do that, I'm left still with that 3y, and it equals 3. Well, just one more operation, and we'll have y by itself. We just need to divide by 3, and we've got it. Y equals 1. So what we have here is an ordered pair. X was 4, y is 1. So this elimination method, most students like a whole lot better because it seems to go a lot faster. There's less work involved. But we can really only use it well when x's and y's are lined up. If x's and y's aren't lined up, it becomes a little bit more cumbersome to end up using, and sometimes substitution is the better method. Well, in part 2, we're going to look at some word problems that we'll end up seeing on future tests.